So please use this video as your introduction to Chapter 2, Lesson 3 as we begin our study of the different biomes that you find in our biosphere, our living world. So we'll only go through the first three on this particular video, and then we'll continue on in class over the other ones. Please use the note paper that I have either for you if you are a remote learner in digital form or the paper that I gave you in class following the science test um, for chapter 2, lessons 1 and 2. All right, so when we start looking at biomes, then we want to understand what we're particularly talking about. So there are several different biomes, and each biome has its own scientific classification and reasoning why it's considered different from the other ones. So when we look at the deserts, we'll look at the rainforest, and there are two different ones, therefore I have two different colors. We have grasslands and savannas would be part of those. We have the deciduous forest, which is where you and I live. We have the boreal forest, and we have the tundra. And then we also have like the mountain and the ice regions. So when we look at what makes a biome different from the other ones, it's mostly based on the climate. What is the average temperature and what is the average amount of precipitation? Once again, as we just talked about in our cycle section, precipitation can be found in rain, snow, sleet, or hail. So we're looking at all four of those categories and the amount that they get within a year's time to determine which of these biome classifications that it's going to use. Then when we end after chapter 2, lesson 3, then we get into chapter 2, lesson 4, where we get into our marine biomes. We'll also have a map that we will color according to our different biomes once we are finished. So the first one that we start with is the desert biome. And when we talk about deserts, we often have a very distinctive look that we think of. If you've ever been to the western part of the United States and areas such as Arizona and Nevada, we know what a desert often looks like. Or if you've seen movies and TVs, they're often depicted the same way. When we're talking about a desert area, we're talking about a specific area that is classified because of the lack of water. So our general images that we have is often sandy, maybe a few plants here and there, but not very often. A lot of sunlight, right? Because they're extremely hot areas. They are actually the hottest areas that we'll find on our planet. And then very few producers, as I said, right? A couple grasses here and there, maybe some cacti, but just not very many. Usually it's pretty sparse when it comes to area, and we don't have an abundance of lakes and rivers and streams that are going to fill that area. So deserts will often look the same, even though these three deserts are located on three different continents. They all look very similar to one another. Right? So when we look at our biomes around the world, it doesn't matter what continent that they are on, because they will all have similar climates. They will also have similar vegetation. They will also have similar consumers. Now, it doesn't mean that in every single desert, I'm going to find a saguaro cactus. It's not the case. Those are pretty dominant in like Mexico and the western part of the United States, but you don't find them in the deserts of Africa per se. It doesn't mean that you're going to find a rattlesnake in all the deserts of the world. They're pretty common to the North America and Mexico deserts, but then when you get into like Australia, they have other types of snakes, right? So similarities in plants, in temperature, in precipitation, and in consumers, but not the exact same organisms. When it comes to the desert, it's going to be the hottest areas because it's affected by direct sunlight. Now, oftentimes people think that deserts are only going to be located on the equator, but that's just simply not the case. If we look at where the sun is shining throughout the seasons, then we have two areas where we're either tilted away from the sun or we're tilted toward the sun. So when we are tilted away from the sun in the northern hemisphere, that's what we call our winter solstice, because the northern part is mostly out of the sunlight. But when we're in the summer, in June to September 23rd, we have our summer solstice and we are leaning closest to the sun. So we actually have the direct sunlight from a little bit below the equator up to the area known as the Tropic of Cancer, where it's getting the most sunlight. When we're leaning away from the sun, then we have a little bit above the equator and stretching down towards the area called the Tropic of Capricorn. So it's those two areas that have the most direct sunlight. And then when we look at the equinox, which is where we're evenly balanced on day and night, the equator itself is what's going to get direct sunlight. So we're talking about the whole center part of the Earth. When I look at this map that's in my book on page 59 and I see the orange sections, it's really going to be those center parts where it's either leaning towards or away from the sun, gets the most direct sunlight. But it's not right on the equator. And we'll talk about why in just a moment. But we're talking about areas that get a lot of evaporation going on, so there's not much precipitation. So in order to be a desert then, it's a classification of less than 25 centimeters of precipitation every year. That's only 9.8 inches, so that's smaller than our regular ruler, right? Because the regular ruler is 12 inches. And if we got that much rain in one day, then we'd think, wow, we got a lot of rain. Or even in a week, wow, we got a lot of rain. But we're talking about 52 weeks, 365 and 1/4 days, that they get less than 10 inches of rain or precipitation every single year. And if that's the case, then it's classified as a desert. But then we have to look at Antarctica, right? Because Antarctica is classified as a desert. Why? Because it gets less than 25 centimeters of precipitation every single year. But it's covered with ice, Mr. B. I know it's covered with ice. And yes, at some point there was precipitation down there, but because it's directly facing away from the sun and pointing to the bottom part of our planet, which is the coldest region, it never is going to get more precipitation, right? So it barely gets any kind of snow, rain, sleet, or hail throughout the entire year, gets less than 10 inches, and therefore it has to be classified as a desert. Notice we're not talking about the temperature, right? We're only classifying it because of its precipitation. Now we kind of flip around. So when we look at, on page 60, the same image, but now we're going to focus on the equator, and we're going to look at two different colors here. We have the green that's really right on the equator, right? Well, most of these regions are thinner strips of land, and therefore those thinner strips of land are surrounded by the ocean water, which at the equator, that's where the majority of our evaporation is happening, and therefore there's a lot of moisture in the air. It's very humid, which in turn brings a whole lot of precipitation. Right, so when we look at these tropical rainforests, we'll talk about the temperate, the purple one, in just a moment. We're talking about an area that has a wide variety of plants, a wide variety of animals, and a whole lot of precipitation that is happening. Different rainforests around the world on 3 different continents, but notice how similar they look to one another. Tall, thick, green leafy plants. Tall trees. We have what's called the canopy of the trees. They're filling up the entire area. And then we have a wide variety of consumers that will be located all over the world in the different tropical rainforests. We have primary consumers, secondary, tertiary, and then we also have the apex. It's not that the exact same plants and the exact same consumers are located in every tropical rainforest. It's the fact that the plants, the producers, and the consumers are similar to one another, and the amount of precipitation is the same. So when we look at these different rainforests, then we can always find different food chains and food webs and how they interact, and we're usually going to find multiple apex predators according to specific food chains and food webs. All of them begin with their energy from the sun, though. A lot of sunlight, therefore there's going to be a lot of extra growth of producers. The more sun, the more producers you're going to have. and therefore they sustain a great deal of our planet. So in the green areas are where the tropical rainforests are located, and those once again. So when we look at the tropical rainforest, we need to understand that there's different layers of growth happening. And the amount of sunlight actually diminishes. It gets smaller from the top all the way down to the bottom. So we're going to start at the bottom where a lot of, ferns and bigger green leafier plants are going to grow, but you don't really have grasses that grow on the forest floor. The reason is there's really not a lot of sunlight. Now, we talked about how tropical rainforests are located at the equator, which has the most direct sunlight throughout the entire year. So why isn't there a lot of sunlight? We'll talk about that in just a moment. But we have a lot of ground dwellers, which are going to be consumers that take place down at the very bottom of the forest floor. But there's not a lot that's going to hold the soil together. So when it is, especially the rainy season, then you're going to have a lot of erosion happening. And therefore, you don't have a lot of grass that's able to grow in and continue to put its roots into the soil. When we look at the center section, then we have what's called the understory layer. The understory is the area that's mostly going to be tree trunks and some vines that are stretched up into the top parts of the trees. There are going to be organisms that survive, specifically consumers, that they thrive in that center section. But it's really kind of an open area where you can just see the tree trunks all around you, surrounded by a whole lot of humidity and moisture in the air. The canopy layer is the reason that there aren't a lot of grasses down below. So when we go to our woods, such as turkey runs or shades, and we go on a hike, we have some pretty thick areas with trees, but then we have open areas as well. And we have a lot of grasses and ferns and plants that can grow. But the canopies, the leaf area of the trees in the tropical rainforest, have large, thick leaves that are covering the entire space of the sky and keeping the sun from getting through the very top where the trees are growing to the bottom where the ferns are. And therefore, those ferns and flowers and plants at the very bottom on the forest floor, they're competing for sunlight. And therefore, that is a limiting factor for them because they don't get as much sunlight as the trees are getting. Then every once in a while we have what is called an emergent layer. So it's not as compacted as it shows in this picture. Generally there's one or two in an acre or two of land, but they're the taller trees that fight through the canopy part to get to the sunlight. So what it would look like in actual areas then, so down in Brazil, one of my older sisters lives there, and some pictures of what it looks like on the forest floor. Notice that there aren't a lot of grasses and shrubs and things that are growing. There are some larger ferns and things like that. And then we get into the canopy section, followed by the understory layer where the tree trunks are and vines are hanging. And then you can see the canopy layer, which is the top of the trees. And then every once in a while you get an emergent tree, which is popping out of the top to get more sunlight and thrive. So these are layers that or areas that have a large amount of diversity, right? So we have a lot of diversity on the floor of the rainforest, a lot of diversity in the understory, and then the canopy, and then the emergent layer, and we can see all sorts of different organisms. They say that there are still thousands of producers and thousands of consumers that we still have not discovered yet in the tropical rainforest because there are just sections that man has never been as far as we know. When we look at the United States, we don't have any tropical rainforests, but we do have one temperate rainforest. So it's classified as a temperate rainforest because just like the tropical rainforest, it receives more than 300 centimeters of rain in a year. So how much water does a tropical rainforest and a temperate rainforest get? More than 300 centimeters of rain in a year. But it's a temperate because it's not located at the equator. It is a warm but mild area, a lot of precipitation, a lot of humidity. We're talking about places like Seattle, Washington, where you get about 60 days of no rain in the year, which means you have 305 days of rain every single year. So that's an area that I personally wouldn't like to live because I don't like getting wet constantly. Some people prefer that type of weather. But it's a mild area, but we still have very similar types of trees. We have very similar types of growth. We have very similar types of producers and consumers that are going to be located there. So these organisms, they don't prefer the really hot areas. They like a more mild climate. We don't see a lot of bears in the tropical rainforest because it's just too hot for them. We see a lot of them that are going to be in our temperate rainforest located in the northwest part of the United States and southwest part of Canada. When we look at these areas, then we're going to find that once again we have many different food chains, many different food webs, how they all interact from producers to primary consumers, secondary consumers, and apex consumers. And then once again, all of that energy starts as the sun. So we have different tropical rainforests located around the equator through each of the different continents other than North America and Antarctica. But we do have a temperate rainforest in North America. Our last one we'll look at on this section is the grasslands. And grasslands are just to the edge usually of a tropical rainforest where it begins to warm up and you're getting closer to like a desert area. Or it's going to be a mild temperature area where moderate amount of precipitation is taking place. So when I look at the grasslands, we're talking about an area that gets anywhere from 25 to 75 centimeters, so a little more than 10 inches, up to about 25 inches of rain. A savanna gets considerably more precipitation, and therefore is able to grow taller grasses. But when we look at these grasslands, then we have many of those out west in the United States. We call it the cereal belt, which is where we grow different grains, not cereals like Captain Crunch, but cereals like oats and wheats and barleys out in the west because we get enough precipitation to be a grassland with mild temperatures to allow these tall grasses to grow, and then we were able to harvest them. We have all sorts of different flowers that we'll find on the different continents, as well as some different types of thicker ornate grasses that grow. Our trees are not our normal trees in the grasslands and savannas. They're usually shorter because there's not as much precipitation as we'll see in the deciduous forest areas and the real forests, but there's enough precipitation for them to grow. The roots can't go as deep as they do in the deciduous forest area, for instance. So therefore, they're usually going to be shorter shrub-like trees compared to the others. When we get into areas like Africa, then notice how open the canopy of that tree is. So a lot of open winds in grasslands. So the trees have to be designed to where the wind can pass through them. So the canopy only goes to the very top of the branches, which would explain why organisms like giraffes have very long necks, so they can get to those tall leaves. If the leaves were filled up on the entire top part of the tree in all of the branches like they are in our area, the winds would cause those trees just simply to get knocked over. But when we look at grasslands, then if we have a lot of grasses, we're going to have a lot of herbivores, right? Organisms that like to eat different plants. And then we have a few carnivores that have to be pretty picky and dominant on what they are going to eat and be able to compete for those other foods. So when we look at a food chain and a food web, then once again we have specific producers, grasses and shrubs and flowers, and then a wide variety of consumers, primary, secondary, tertiary, and apex, depending on which continent that you're on. But they all have some very similar qualities in each of their levels. And even in the grasslands, the sun is the beginning of all energy that's going to flow throughout it. So when we look at the grasslands and where they're found, we can see that they're found in Asia, they're found in Africa, they're found in South America, they're found in North America. So they're on all of the major continents of our world.